So yesterday we learned one of the two methods for dividing a polynomial by another polynomial. Some of you may have guessed, I don't know, or maybe you've talked to somebody who's taken this course before or something like that, but maybe you may not know why we're doing this or how this is going to be helpful. Like right now we're just learning an algorithm. Yesterday we learned one method, today we're learning a different method. Remember I told you you'd have a favorite. We're just learning an algorithm, but then starting a little bit tomorrow, but then even more on Monday, we're going to see how useful these algorithms are and what we can do with them. If you've already guessed, that's fantastic, but we're going somewhere that's a big deal with this stuff. What was the method called yesterday? Thank you, long division. So we were dividing polynomials by polynomials with long division, or polynomial long division, maybe you call it something like that. This one's called synthetic division, okay? You probably want to know it by name. It's a popular name, like you could look it up on the internet, that kind of thing. You'd find videos. It's called synthetic division, okay? So a quick recap of the notation. Again, the notation is very useful. It's just a really useful communication tool. And for this unit and next unit where we do more polynomial stuff, but then the next unit as well, we use this notation a lot, like r at x for a remainder when we do a whole big new thing that we do in the next unit. So this stuff doesn't go away, so it's useful. So we're going to just talk about it quickly again. And remember, I think we wrote this down yesterday, but whether or not we did or we didn't, we're going to write it down again. It goes like this. D at x divides, oh, it's frozen, thank you. Divides into f at x, and then you do some work, and that you calculate q at x, and like dot, dot, dot down here is r at x, your remainder. The example we did yesterday was, I believe, one of them. 5 divides into 123. We got 24 as our quotient. So 5 goes into 123, 24 whole times, dot, dot, dot. Our remainder was 3. And remember, we wrote out this division statement. It might seem, I mean, it's not that tedious because it's not that long, but it might seem like not useful, but take my word for it, it is. And that's the same thing as saying 123 is equal to 5 times 24, which is 120, plus 3, which is 123.
So because it's multiplication, is it okay to swap D and Q?
Yeah.
It is? Yeah.
I would get in the habit of writing it the same way. D is usually more simple than Q. And so sometimes we kind of write that out front, but it's not really wrong. Okay, just a recap of yesterday. This could be useful to look and like remember what the division statement means when you have these two things written side by side, and remember what goes where and what's called what. But in the end, you want to know how to do the process of long division. Everybody's good with that? All right, here we go with synthetic division. Divide each polynomial by the given divisor using synthetic division. Now I'm going to tell you this. There will be times where you get a choice of whether you want to use long division or synthetic, and you can use your favorite. But there is a situation where you have to use one of them. I'll talk about that after we've done a couple of examples of this. Okay? And so sometimes, most of the time, almost all the time, you'll have choice. But there's one situation where you don't, and you have to use a particular method. Okay? But if the instructions say use synthetic division, then obviously you have to use synthetic division because I told you to use synthetic division, right? Like these ones, and if you look at the worksheet for today, one of the questions says use synthetic division because we're supposed to be practicing it. And if it says using long division, then you must use long division just because you were told. Always do what you're told. Everybody ready? You got this copied down? There's our f at x, there's our d at x. Is you ready to start? The very first step kind of looks like what we were doing yesterday, but it's not the same. We do write x plus 2, the thing our divisor, the thing we're dividing into the other thing. Hold on, pause. Do you remember when you learned complex trinomial factoring in grade 10? Sort of, at least. Do you remember the first time your teacher did it? And they're like doing all this stuff, and you write out the factors, and you're multiplying and everything, and then you circle them, and then your teacher writes the answer, and then you move to the next example, and you're like, whoa, wait, what? What just happened there? I understood everything up until that very last step where you wrote the answer. Like, where did that answer come from? It's a strange algorithm that if you pull it apart, you can see why it works, but I don't think it's obvious. But it works every time. It's this awesome magical trick that works every time, complex trinomial factoring. In the beginning, this looks like that, okay? So it's a little like, why are you doing that? Why did you do that? Don't ask that yet, okay? I'll touch briefly on why, and you can go and look at why, but we're not going to worry too much about why. This is just a useful tool, so don't ask why, at least not yet. Okay, so we write down the thing we're dividing into the other thing. We draw a line that goes 2 lines down. Does that make sense? You see what I mean? Like it's a long line, it's 2 lines long. Does that make sense, sort of? Then we go to the dividend, which is a word you don't really need to know, but it's f of x. And this one, there's no trick to this one. This one's straightforward. And here's the part that like you wouldn't guess necessarily, but we just write down the coefficients. And just like yesterday, you need a coefficient for every term, so you would need a placeholder or a ghost term if you needed one, but I don't think we do for this one. I've got an x cubed, an x squared, an x, and a constant. So the coefficient of the x cubed term is 1. Coefficient of the x squared term is -5. I'm just writing down the coefficients. Of the x term is -1, and the constant is 12. Then I draw a line down here. Now, if you went and looked this up on the internet videos, the notation is not always consistent. Some people draw the line above, some people draw the line below, like it's kind of all over the place. So don't worry too much about where the line goes, okay? But this is how I do it. Kind of looks like an upside down division sign, doesn't it? Okay. So here's what we do. Now, it's just like kind of like complex trinomial factoring, it's an algorithm that you kind of just memorize. The one from yesterday, I think you can kind of make sense of. You can make sense of this one as well, but it won't make sense in the beginning. Ready? You take the first coefficient, which also has to be in order, of course, right? So this one was written in order. If it wasn't written in order, you'd have to fix it. So this is going to be the coefficient of the highest degree term. The whole polynomial is degree 3. And I just take this down below the line. Then I take this and I multiply it by this and I put my answer there. 1 times 2 is 2. Then I subtract. -5 minus 2, -7. Then I repeat till we have no more numbers left. So now it's -7 times 2, and I put my answer in the next empty spot. So that's -14. -1 minus -14 is -1 plus 14, which is 13. Repeat, 13 times 2 is 26. Am I going too fast? Is everybody keeping up okay? 12 minus 26 is 14. Put a box around that, and obviously we're done. There's your answer, and we move on to the next example. See, oh, -14, thank you. We're done though, right? That's your answer? And you're like, what? What are you talking about? There's nothing. What does this even mean? Samir, what do you think? Very close. Very good. These are the coefficients of our answer because we started with the coefficients, so our answer is here. Now there's something about, hold on. This is important. Remember yesterday, we talked a little bit about how, like, if you have a degree 4 and you're dividing by a degree 2, we can predict what the degree of our quotient is going to be. it's going to be degree 2. You're like subtracting degrees kind of thing, right? Or if I have a cubic and I divide by a degree 1, my result will be degree 2. Do you remember doing that? Okay, good, thank you. Here's our example of that, right? So I had a quartic dividing by a degree 1, and my result was degree 3. Or this one, I have a quartic dividing by degree 2, and I have degree 2 because when I remultiply, it's going to be this times this, which has to give me back that. Like, this is important to think about. It's not part of the process, but it will help you make more sense of what you're doing. And for synthetic division, because the answer doesn't just pop out, we need to know that I started with a cubic divided by a linear term, a degree 1 term or factor here. And so this is going to be quadratic, degree 2. Now, quadratics are also the only one with 3 terms. So I could maybe figure it out with that, but I think it's helpful to know. And no, one's in a box. And why wouldn't you put one in a box? And and remember when yesterday we were writing out the division statement every time, and maybe you thought you didn't really have to, it's kind of a waste of time. Well, like looking at this, there's no answer, right? So writing out the division statement is also us writing it back out as an actual polynomial. So let's do that. F at x equals d. I'm going to write this one time. D at x times q at x plus, wait a minute, r at x, what's that? No, it's in the box. D at x is x plus 2. Q at x is 1x squared minus 7x plus 13. And my remainder is in the box. We put it in a box to remind ourselves that it's the remainder and to sort of take note of it. And it turns out in a couple of days when we start using this, what the remainder is a big deal. Want to do another one? Any questions? Yes?
What if x has a coefficient? Like the
X squared? Like
x plus 2. What if the x has a...
Good question. Hold on for about 10 minutes and then I'll answer. So you got to set it up. You got to know how to set it up. Again, this is not something that you could just look at my note online and be like, oh, yeah, okay, that's where all those random numbers came from. Like, it wouldn't be obvious, right? You got to kind of watch it happen in motion. And you got to set it up right. So x minus 2 goes over there. I just write out the coefficients. 2. Oh, what do we notice about this one? Right. So placeholder term, ghost term, we just got to put a 0 in. So 2, 5, 0, -7, and 10. Now you see why the line has to be too long, right? Some of the numbers go inside and some go below, so we split our answer from the rest of it. Everybody ready? You might want to just kind of watch me do this one again, right? So like you could try if you think you know what to do, but remember we bring down the 2 to start. And then I go 2 times -2, and I put my answer there. 2 times -2 is -4. 5 minus -4 is 9. 9 times -2 is -18. 0 minus -18, 0 plus 18 is 18. 18 times -2 is -36. -7 minus -36 plus 36 is 29. -2 times 29 is -58. 10 minus negative 58 is plus 58 is 68, and we're done. Put a box around that. And then write out our division statement. So this one is, what's the degree of my quotient going to be? Right, degree 3. So it's going to be like, and if you were missing a term in your quotient, you would have a coefficient of 0 there. That would work out just fine. That would come out in the system, right? So I got x cubed, x squared, x, and constant. So see what I mean? Like this can't be quadratic or anything else. But we also know, because we started with degree 4 and we divided by degree 1, our result is going to be degree 3. That's something you should be thinking of and you should know. So we get 2x cubed plus 9x squared plus 18x plus 29 bracket plus 68. All positive. That's interesting. But anyway. It's just random. Usually it doesn't work out that way. We good? Anybody recognize that example? Very good. That was the exact one we did yesterday. Keep it on your sheet. Take a look at these numbers. Negative 4, negative 18, negative 36, negative 58. Here it is from yesterday. That's not it. Ready? Negative 4, negative 18, negative 36, negative 58. Synthetic division is really just long division without all the extra junk. It's just using the parts that we need. Whoever came up with this was brilliant. Do you have a favorite? Do you like one better than the other? Okay, let's keep going. Oh, here's the trick though, as you're copying this down. You may have a favorite that you want to use all the time, but if I am dividing by anything more than a linear term, like an x squared term, like we did an example of that yesterday, synthetic division does not work with that. So the third example we did yesterday, where you're dividing by x squared plus x plus 2 or whatever it was, you have to use long division for that. So even if you don't like long division because it's a lot more writing, and you get really fast at using synthetic, you can't use synthetic in every situation. The nice thing is most of what we do throughout the rest of this course is dividing by terms like this. So most of the time, almost all the time, you'll be able to use synthetic. Okay, what do we notice that's different about this one? It's got a coefficient in front of the x in the linear term that we're dividing by. So this was Lucas's question a few minutes ago. What would we do? How would we do that? I love it when people predict. There's no ghost terms here, are there? Fourth, third, second, first, 0. Good. I love it when people predict what's coming up next. Like you're actually thinking about this. It's fantastic. Very close, not quite. Everybody ready to go? First step is the same. I bring down the 2. But here's where I take this 2, I divide by whatever this is, and it should divide nicely because you shouldn't have fractions in your coefficients. That's not normal. So I do this divided by this. So I get 1. And then I take the 1, multiply it by the constant. 1 times 1 is 1. I put it here. 7 minus 1 is 6. 6 divided by 2 is 3. So one extra step, I divide by the coefficient. 3 times 1 is 3. 13 minus 3 is 10. If I was ever doing this process and, like I say, it didn't work out, like you got a decimal or a fraction when you divide it, you've made a mistake. Go back and fix it. 13 divided by 3 is 10. 10 divided by 2 is 5. 5 times 1 is 5. 25 minus 5 is 20. Divided by 2 is 10. 1 times 10 is 10. 10 minus 10 is 0, like somebody just said. There's no remainder. By the way, don't divide the remainder by the 2.
So if there was a number there, you wouldn't.
Correct. You would not divide it. And this bottom line is our answer. How could I quickly check and remind myself which one is correct? So plus 0 in this case. Like, what if I did this whole process and then because it's a quiz and I, a little bit nervous, I forgot if it's that line or that line when you get the answer. Anybody see how you could check that? Max?
You just check the x by 4. So it would be 4x by 4 instead of 2x by 4.
I think, yes. I think I understand what you're saying. In other words, expand 2x times x cubed is 2x to the 4th. Otherwise, you get 4x to the 4th if you multiplied by this. So you can always re-expand, even if you just re-expand a little bit. It's at least a bit of a check.
And we need to write the 0 at the end?
For today, I would. Down the road, you certainly won't have to. No. But for today, I would.
Just make sure it's like if in the box there was 2, you still would include the x.
Correct.
Would there ever be a question in which synthetic would only work over long division?
No. Good question. No. Long division works for everything. Synthetic's just shorter. All right, I want you to try this one. See how far you can get. See if you can at least get it set up.
What is the situation where you have to use long division?
When you're dividing by something that's not a linear factor, so like x squared. Synthetic division won't work.
Okay, well, it didn't work in long division either.
That's probably because you missed the ghost term.
Oh, there was a ghost term. Oh my god.
There's another way of doing synthetic division as well. Again, as a heads up, if you were to look up somebody else's video. I don't recommend it. It's a different setup, and then the steps are slightly different. So like you're going to totally confuse yourself if you're watching some people do it this way and other people do it the other way. So it works, but to me it's a bit more confusing, and this one's more like long division. So I would stick with this one if I was you, but. Wait, that's your answer. That's your answer.
Oh yeah, it is. Those are questions you want.
Here's your setup, what it should look like.
So on the test, what's on the test?
Okay, and there you go.